There is a wall design that can drop your indoor temperature by 10 to 15 degrees Fahrenheit in the peak of summer without a single moving part or any electricity. No compressor, no fan, no monthly bill. And yet, almost nobody is building with it. This isn't just a wall. It's a passive cooling system built into the structure itself, using nothing but sunlight and physics. What you're looking at is a silent solar heat engine embedded in your wall that can outperform modern air conditioning. But here's where it gets interesting. Imagine a house that lives and breathes. In our typical homes, we seal everything tight and blast AC to fight heat. But that approach is fundamentally flawed. We trap heat inside a thin plastic-wrapped box, then spend thousands of dollars powering a machine to push it back out. An air conditioner doesn't remove heat. It grabs indoor heat, compresses it, and shoves it outdoors, consuming massive electricity in the process. And the hotter it is outside, the harder the AC has to work, becoming less efficient by the minute. In many regions, air conditioning alone is more than 50% of a home's summer electricity use. Yet even with all that power, our homes still bake. What if instead the walls themselves worked for us? What if your walls could control heat, ventilate air, and cool your house for free? That is exactly what this ancient wall design does. The story begins 3,000 years ago, not in a lab, but on the blazing plateaus of Persia, today's Iran. Cities like Yazd baked under 45 degrees Celsius, 113 degrees Fahrenheit, summers. People had no electricity and no refrigerant, yet they survived. How? By mastering air and mass. They built enormous wind towers and thick masonry walls called bad gears. These weren't decorative. They were the world's first solar heat engines. The mass of stone and earth absorbed the sun's heat all day, then slowly released it at night. Crucially, they understood thermal lag, the idea that a thick wall can absorb heat and delay its passage until the cool night. The result, the hottest sunlight at 2 p.m. doesn't hit the living room until midnight, when it's already cool outside. This passive strategy kept rooms naturally cool during the day. This isn't high-tech magic, it's just physics. During the day, solar energy heats a dark absorber on the wall. The heat is stored in the thick wall material and moves very slowly. By the time it reaches the room side, it's well past sunset and easy to flush out. No electricity, no moving parts. This thermal mass strategy alone can delay heat transfer by 8 to 12 hours, effectively carrying the day's heat away into the cool night. But it gets even better. The wall doesn't just store heat, it actively moves air. This is where the atmospheric engine kicks in. Picture this, a solar heated air chamber built into the wall with vents at the top and bottom. As the sun heats the air inside, that air becomes lighter, lower density, and rises up through the top vent. It's as if the wall is sipping air from below and exhaling it out the top. By Bernoulli's principle and the ideal gas law, the warmer air rushes up and out, creating a slight vacuum at the bottom. The house, unwilling to let a vacuum remain, inhales fresh, cool air through the lower vent. The cycle is continuous and self-regulating. More sun means more heat, which means faster airflow. On a 100 degrees Fahrenheit afternoon, when a mechanical AC struggles the most, this passive system is at its peak, moving hundreds or even thousands of cubic feet of air per hour, all without a single watt of power. This isn't just a hypothesis. In the Sonoran Desert, Researchers at the University of Arizona built exactly this kind of system and watched the numbers. On a sweltering day, the indoor air stayed at 24 degrees Celsius, 75 degrees Fahrenheit, while outside it was 41 degrees Celsius, 106 degrees Fahrenheit. A 17 degrees Fahrenheit cooler interior achieved solely by the weight of the atmosphere and the heat of the sun. No electricity was used at all. The benefits go beyond temperature. The Environmental Protection Agency notes that indoor air can be 2 to 5 times more polluted than outdoor air. In a tightly sealed recirculating HVAC house, fresh air changes per hour are typically less than 0.5. Most air just goes in circles. By contrast, this passive wall can deliver 8 to 12 air changes per hour of 100% outdoor air, like opening every window simultaneously, but without the energy loss or security risk. It flushes out volatile chemicals, CO2, moisture, everything that builds up in sick buildings. In effect, it's a zero-energy ventilation and cooling machine. No wonder one study found that homes using this approach cut their overall cooling energy consumption by up to 75%. Think about it. The same solar heat that would normally make your AC scream is actually powering the fan-free cooling. The hotter and sunnier the day, the stronger the airflow. It's an elegant dance of thermodynamics. And the environmental payoff is massive. Building, installing, and running a standard 3-ton central AC for 15 years emits roughly 25 tons of CO2 over its lifetime. By contrast, a heavy-duty masonry wall with glass and aluminum has a carbon payback in months. Once built, its operating cost and emissions are essentially zero. This wall turns carbon debt into a carbon-negative asset on your home. So why isn't every house built this way? Why is a near-zero energy solution still so rare? The answer lies in economics and regulations. The construction and HVAC industries are built on predictability and profit. It's far easier for a developer to erect a cheap, stick-built box and then call an AC contractor. That's a known cost with recurring revenue. The machine will break down, need new filters, refrigerant refills, and eat electricity for years. And all of that is profit for someone. By contrast, a passive wall never breaks, never needs a filter, and never sends a monthly bill. Worse, building codes have been written with machines in mind. The U.S. International Residential Code, IRC, and ASHRAE 62.2 standards assume mechanical ventilation. Because this wall's performance varies with the sun, it isn't a certifiable product with an Energy Star label. Inspectors often demand a backup fan or AC system as insurance, effectively doubling the cost and forcing buyers to pay for a machine they don't need. In short, the passive wall falls through the bureaucratic cracks. We're told mechanical is modern and passive is primitive, when in reality, brute force machines are the primitive, temporary fix. What would it look like to install this yourself? For an existing home, the simplest retrofit is a south-facing ventilated tromba wall. Imagine an insulated box attached to your sunniest wall. Inside it is a dark absorber plate, painted with a selective solar coating, behind low emissivity glass. You cut a vent at floor level and another at the ceiling of your house. As the sun heats the absorber, air behind the glass rises and escapes out the top vent, drawing cool room air in from the bottom. For a room of about 500 square feet, approximately 45 square meters, you'd need roughly 20 square feet, approximately 2 square meters, of solar collector area. roughly the size of a small wall or several large windows. The good news, the materials are cheap. UV-resistant polycarbonate or insulated aluminum panels, high-temperature silicone filter screens. A DIY retrofit can cost on the order of $300 to $500 in parts. Once built, you just open the bottom vent and close the top vent, or vice versa, depending on season. For new construction, you can go further. Architects can design tall thermal chimneys into the very fabric of the house. Picture integrated vertical shafts 20 to 30 feet high built into the south or west walls, lined with dark masonry or metal and glazed with low iron glass. You place the air intake at the lowest shady point. In fact, pairing it with an earth-to-air heat exchanger pushes efficiency to the extreme. By burying a approximately 100-foot pipe 6 to 8 feet underground, where the soil stays about 12 degrees Celsius / 54 degrees Fahrenheit year-round, the incoming air is pre-cooled before it reaches the living space. The solar chimney then pulls that 54 degrees Fahrenheit air up into your home. The result? A no-watt air conditioner that still cools your house even during a blackout. Maintenance is almost non-existent. There are no mechanical parts to fail. An annual check of any insect screens or filters on the intake and a quick wipe of the glazing for dust are all you need. That's it. Unlike a traditional AC's yearly $200 tune-up, this wall is a permanent organ of your house, not an appliance with a 15-year shelf life. In the end, the simple physics speaks for itself. A thick, sun-facing wall can turn sunlight into fresh airflow that cools and ventilates simultaneously. It's a 3,000-year-old idea proven in the desert, hospitals, and now in modern field tests. When we allow physics to do the work, our homes become self-regulating ecosystems. We ditch the electric bills, the carbon emissions, and the sick building symptoms, all by embracing a little-known passive design. If high-performance, self-sufficient homes matter to you, then keep this knowledge alive. Comment, share, and subscribe. Let's rediscover the lost art of building homes that breathe with the laws of nature.